Hi everyone, today I'm with Cedric and Mathilde. Hello, I'm in their house that they built themselves with load-bearing straw. So it's straw that supports the whole house and insulates it at the same time. The house is 84 square meters with straw, a very eco-friendly and innovative technique. Let me show you, let's begin.
So it's a house that we built on a pétanque court. Actually, there's a hotel restaurant just behind us here. And so it's a very narrow plot. It's 10 meters wide by 20 meters long. So it's actually really small. And the big challenge was that we actually had 3 mature plane trees that we had to keep. So we kind of slid the house in between the trees like that. And also the shape of the house is a bit unusual because actually the upper floor couldn't be as wide as the ground floor. And because of zoning regulations, actually, because of urban regulations, the ground floor is about 50 square meters and the upper floor is about 30, 35, 25. And there you go, that gives me a small house of 80 to 84 square meters.
You have the constraint from the old pétanque court and also need to keep the trees, which leads to architectural choices. In the back you can see all the windows since we're facing due south. The house has load-bearing straw walls, but there's still a lot of visible wood.
Yeah, absolutely. It's true that we're using a load-bearing straw system. Some walls rely on straw for support, while others do not. We'll go into a bit more detail where it's mainly the wood that takes the load, especially on the south facade, because we have lots and lots of windows to actually capture solar gains in the winter. The entire facade is made of glass, so those big posts you see there, they take the load.
Well, we can go inside and take a look.
Yeah, absolutely.
Well, we're in the main room, actually the only room on this first floor.
Yeah, that's true. We wanted to have a big room because the house isn't very big, so we still wanted to have a feeling of space. So it's 45 square meters.
And so you can see the walls, we put straw directly, and on top of that, an earth plaster, that's right?
That's right, it's an earth plaster. Here too we chose a very light clay, we chose kaolin and a light colored sand. The sand is the same as the one used for the screed, so that's what we did. As a result, this finish is very, 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 very bright. It's a kind of off-white cream color. It's a plaster that's reinforced with small pieces of chopped straw mixed into the plaster, and that's the finish. Maybe in the bathroom we'll see the rough base coat plaster.
And what's the advantage of using a plaster? Is it economical, ecological?
So for load-bearing straw, it contributes to the structure. It provides bracing actually for load-bearing straw. It has many uses and provides airtightness, which is interesting because it eliminates the need for all those films. And then it also acts as a hygrometric buffer. That means that when we live like this in the house, we generate water vapor, and so it will capture it and release it later. And so as a result, the air is not very humid actually, so it's quite pleasant to live in.
Okay, so I imagine there's an economic benefit because it must be cheaper. There must be other materials since it's still made of earth.
Yes, it's not very expensive, that's true. Earth plaster isn't very expensive in terms of materials. It's not very costly. But when it's applied by professionals, it's a bit more expensive because it does take quite a bit of time.
Costlier than traditional systems.
It depends on the system, but overall, it's still not a cheap solution.
But if you do it as a self-build, and what isn't, I imagine, ultra complicated, it's a lot of time, I guess, to apply.
It's not very complicated, but there are still things you need to know, of course, just like with many techniques. But really, someone who is quite conscientious can manage it pretty easily. And
okay, so I'm curious for you to show a bit to the room.
Yeah.
I think it's a room that tells a lot of stories. The wall, the straw, you can see the skylight, a lot of beautiful things to look at.
Well, actually, as pastry chefs, we never finished it because we thought it was beautiful just the way it is. You can actually see the slightly long fibers that we put in the mixture. It's actually straw from the construction site that we chopped and added to the mix. That on the rough side is kind of nice, and then this is the real deal. It actually lets you see the wall, the straw wall that's behind it.
His window of truth. We really put straw in our wall. See? And what's this for? It's funny, that's why.
It's
how innovative it is and that we want to show people. Really.
Yeah, and even for us to remind ourselves that there's really straw behind it. Sometimes we kind of forget that it's straw that's holding up the structure, you know.
And then you were saying in the bathroom, having an earth plaster, when it comes to humidity, it works really, really well.
It's super nice because as a result, it's actually a room that's not very humid at all. And the bath towels dry really fast, even the steam on the mirror, you know, all those little details. Really, the humidity doesn't stay, actually. It goes straight into the walls.
Is that because of the earth or the earth and straw together?
No, mostly thanks to the earth. Actually, it's the earth that will absorb the ambient humidity and then slowly release it. Actually, in an earth plaster, there's clay, sand, in our case straw, and so water, but it's mainly the clay. Actually, it's the properties of the clay that absorb the humidity.
Okay, let's go check out the kitchen because I think it's just as interesting. So here, the very large kitchen. Indeed, you even wonder where the kitchen is, right? Why? Why did you choose to have a very, very small kitchen?
Well, that's part of the kitchen. It's kind of like the annex of the kitchen. Things are a bit spread out. Actually, the sink is over there, the cooktop is over there, and the counter is over there in the back. It's kind of an aesthetic choice, you know, to hide all the guts of the kitchen, so to speak.
But also a minimalist intent, since the kitchen ultimately occupies little space. You can't see the cooktop or even tell there's a kitchen. It could just look like an office or something decorative.
Yeah, and actually it's very functional. At first we didn't know. After we started using it, it worked well.
It's fine, we're reassured. In the report, you still eat, so you're reassured they eat. It's true. We can go see the upstairs now. Oh look, that's the sink we mentioned. It's right there and has been reused. It appears to be a school sink.
Yeah, we tried for everything that's sanitary furniture, even the radiators, we tried to buy a lot of things secondhand, so if it was possible, we tried to do it.
And by the way, we haven't discussed heating. How do you heat yourselves here?
Well, we have a small radiator. You see, it's really small over there, electric, 1,000 watts.
And it manages to heat up the place. Both floors and the whole house stay warm, so you don't need heavy jackets inside.
No, we're sensitive to the cold.
And he was telling me it's true that before, about 200 euros a year for heating, more or less. Yeah, it's aesthetic, a bit modern, but at the same time simple.
Yeah, we like it. We like the mix of different eras a bit.
Yeah, and then it's really bright, you know, with all the bay windows, especially upstairs. Are you going to give us a little tip? Self-construction. So, the floor, which you said is about 25 square meters, that's it, smaller downstairs?
Yeah, that's right. We had this issue with the setback from the neighbor's property line, so the upper floor is narrower. And so we decided to have 2 small bedrooms, including one that's really tiny, about 7 square meters, which opens onto a landing. So it's true that we don't have much space to move around. Lost, yeah. And also, it's really important to think about everything related to blocking out light, because it's true that it's hard for us to imagine. Since these are very well insulated houses, they really work like a thermos. So if heat gets into the thermos, the heat stays in. So it's really important to think about blocking out the facades. East and west and south too. So for us, for example, on the east side, we have sunbreakers. So that way we don't get any of the morning sun. Basically, we close them like this starting around April to avoid overheating. And it's the same on the west and south sides. We have plane trees. So in the south, we're well shaded in the summer.
And why didn't you install regular roller shutters? Why did you choose sunbreakers?
Sunbreakers are great since they're adjustable and let you switch things up easily. You can still see through them, but at the same time be protected from the sun. So that's really interesting.
Okay, we'll talk more about that off the record because I'm really interested, but for now. So let's check out the last room, the office. So the last room in the house, the guest bedroom, photo studio. A lot of things actually. And why did I want us to finish here? Because there's something very interesting. It's that you didn't put professional window frames everywhere that are expensive. Ultimately, you discovered an inexpensive do-it-yourself trick: buy glass panes separately and fit them into your wooden frames. Can you explain to us a bit why you did that and how you did it?
That's exactly it. Since we have a lot of glass surface, it was interesting to find a technique so we wouldn't have to buy window frames like that 12 times, I think. So actually we bought glass panes like this, so the glass is already made. It's triple glazing that we buy by ourselves to the right dimensions. It's made to order, so from memory I think it's about 250, the large panes like that, so they're very, very heavy. The biggest ones weigh 200 kilograms. Still, you need to have some equipment, you need suction cups to get them to their destination safely. The glass is placed directly against the wooden structure, so it's not up to code, but we haven't had any problems. It hasn't cracked, it's very watertight, airtight, all of that. So actually the glass is embedded like this in front of the post, the facade post, and behind, so that's also the wooden post. And so there's this little closing part that's screwed in like this, and it pinches the glass.
Yes, the glass sits between two wooden plates, sealed to make it airtight and watertight. And when you say it's not up to code, what are the risks if we do that?
If the structure deforms, there's a small risk of breakage.
You said there were a few small cracks in the triple glazing, but not because of that.
Not at all, it's due to deformations. Triple glazing is actually becoming a known issue on construction sites. Because actually, if you put something like a comforter here on the floor, there will be differential expansion at the comforter, and as a result, it will break the glazing.
Thank you for visiting. Now we'll review the technical details. Alright, let's go. We'll review some technical aspects of how this was built together. But to start, why a straw house? Actually, what's the point of doing this with straw?
Because straw is a very good insulator. It's a local insulator from short supply chains, and most importantly, it's a waste or byproduct. There's always a bit of ambivalence, a little debate about whether it's a byproduct or not. So the advantage of the straw bale is that we're really working with a very, very short supply chain with significant social involvement. It's important because you can process it yourself and use it for both insulation and structure.
Since it serves as both insulation and structure, is its main advantage cost savings? Do we save on both materials? Since straw isn't expensive, well, that's one of the advantages of building with straw after all.
Actually, we don't really save that much. It's just really efficient. You should really look at the savings in the long term. With load-bearing or infill straw, we're not always cheaper than other highly efficient solutions, because actually the price of the walls in a house is less than 20% of the total price of the house. So as a result, the straw itself, if we don't make an impact on the overall design, on the carpentry, on pretty much every aspect, it'll be hard to really make something very economical. Afterwards, we'll have something different. It's about having a house with an extremely well-insulated thermal envelope. So for heating, we're spending under 200 euros a year on a house that's nearly passive. And the average in France, I checked the stats again this week, heating a fairly standard house costs about 1,700 euros per year. What if everything is well designed and goes as planned? Actually, if we manage to save 20 to 30% on all the items, which is possible, as we've seen in the captions, we can really benefit from that. Ultimately, we can build a passive building that's slightly pricier than polystyrene cinder blocks, allows minimal airflow, and just meets the Aero 2020 standard. But with bio-based materials, we can do it.
And so in terms of cost, the house then, 85 square meters, how much did it cost you? How much did you spend?
Our renovation budget is 180,000 euros. 180,000 euros including tax for 84 square meters, okay?
You know, about the small annex outside where you've planned to add 25 square meters.
So for about 10,000 euros more, we could go from 84 to almost 110 square meters, an increase of about 25 square meters. We would be at 190,000 euros. So now it becomes very interesting.
Well, 190,000 for 110 square meters, or a quick mental calculation. But we're at 1,700, 1,800 euros per square meter, including tax. For a passive house, it's easy. I'm not sure if it's really your house. We didn't do it or get certified, but we're nearly passive. And all of this still remains quite attractive from a price point of view. It might scare people. 190,000 euros is no longer in the economic house. But since heating costs are nearly zero due to passive systems, there's still potential. 110 square meters, actually.
Yes, and then it's part of the choices we made, actually. It's true that we treated ourselves by putting in a nice hardwood floor. We have quality woodwork that's made in France within 100 kilometers. So there are places where we said, okay, we'll spend the money here, even though we could have done it for less.
So to sum up the question of price, we can say it's not super affordable like you might imagine. Straw that costs nothing because there's still a technique and labor involved behind it. But for a passive house, and for a house like this, it's not much more expensive than the others. Ultimately, it's even cheaper when you factor in the passive benefits and quality of life.
And then the savings on the bills, that's it. To save money, avoid including architecture as we did here, where it's already part of the design. Because of the constraints of the local urban plan, the city, the trees and all that, and we knew very well that we wouldn't set a financial record. Our main goals were to prove load-bearing straw works for modern designs, is suitable for city construction, can make perfectly straight walls, and can be built with community involvement. With a 10-year warranty, so basically we set the bar as high as possible everywhere. Today, we could do it. If we did it again, we would do it for less, maybe make some different choices, but really to get into truly economical construction, you have to go for a much simpler architecture. Already in terms of form, that's for sure.
Okay, I hope that answer satisfies you. As for the price, we can keep discussing it in the comments. But I know this is a point where a lot of people are really curious about the economic side of things. Many people were frustrated without a price to know if it's expensive. I think we answered that better this time. I hope so. Now you're saying we need to design our project well. Exactly. What skills are needed to build with straw? Is it easier than other construction methods? Because in the end, are we just stacking straw and it's load bearing, or is it actually more complicated than that?
No, it seems simple, and I think that's part of why there's been such enthusiasm for load-bearing straw over the past 5 years. It seems simple. You stack bales, but there's more to it than that. It's more accessible, but the complication is that it's actually a dry-laid masonry block. When you get it from the fields, it's a bit twisted. Really, these are just simple actions. You have to have seen them at least once, because often what you see on self-builders sites is that they take the bales directly and stack them very quickly. The building will be constructed, but the walls will have trouble having clean lines, being straight. And what is that? Does it cause structural issues, or is it just cosmetic? It can be both, or just cosmetic. If it suits people, it's their choice. It can also be structural. Because actually the ways walls can break, load-bearing straw panels are made of straw sandwiched between plaster on both sides.
Which ones provide bracing for the straw, as you mentioned?
Yes, it's really like an airplane's composite sandwich panel with foam and aluminum. Actually, we have straw bales and thick coatings on each side. So in fact, in the terminology, we should call these thin membranes. Working, it's a load-bearing element, and actually the coatings alone, none would support it, not even the straw, but together their combined effects multiply rather than just add. Load-bearing straw, it's just less common. There are actually a lot of techniques. I just think it's a bit of a shame to make them up yourself on site, when actually they're already known by a community in France. We train on participatory work sites, and we also train in 2-day formats, 5-day formats. These are trainings that we try to make not too expensive, The idea is that people leave with at least the right techniques. So if they have to innovate, it's not on things we already know actually.
Since your project is original and complex, it needs extensive research and structure. If they made it a simple square or rectangle, there wouldn't be so many questions. It's very technical.
No, it definitely would have been much simpler, but I still think it's worth it once you go beyond a small space. At the scale of a house or structure, costs aren't very high, even at the end. In all conventional houses, structural studies are carried out. They're usually included in the masonry or carpentry cost. In any case, there are some, and so I think it's not necessarily relevant to skip them for a house, not for all. We save money through design because we'll be able to size the columns and beams more precisely. Now we can say that's enough, while before we often doubled it to be safe. I'm not sure a beam can span 3 meters, a wine beam, I don't know, from the class with a 40 beam, and then in sequence.
It's better to do more studies beforehand to know what we're putting in rather than wanting to put in too much and lose money on that. That's it. And so the second part of this discussion, I'd like us to go step by step through how you built the house, starting with the foundations. What did you choose to put under your house? Straw?
No, not at all. We had to make some decisions. Actually, with all the options we set here and there, we had them. We went with a solution, radier, so there you go. Concrete works perfectly with these thick walls. We were less experienced with justifying the anchors back then. The advantage was the raft foundation. It's really the concrete slab that takes the whole load at the end of the year, a bit thicker than usual, not as deep either, but it takes everything. So we can anchor across the whole slab. So for us it made things safer here, so we have the concrete raft on top. We bought a second-hand TMS. It's a polyurethane. This one, we chose it carefully. It's a polyurethane that doesn't release any formaldehyde. It was okay. After that, we made compromises, mainly about the budget.
Indeed, the insulation, the somewhat eco-friendly side, concrete slab plus polyurethane, it's not the most eco-friendly option. But do you have any other solutions?
We could have used a wooden slab like in Villeurbanne, slightly raised, so it would still be on concrete pads, right? Concrete pads, helical piles, but the ground here, helical piles were very, very close to the water table.
We should have run deeper tests. With helical piles, you could have used a concrete slab, a wooden raft with watts or something else. That's it.
We could have done that later. The problem is, we wanted to keep it architectural and pursue our ambitions as architects while enjoying the process. We also aim for continuous flooring outside. Switching to wood slab pilory systems creates an immediate step compared to the outside. We made a decision, we went with masonry, we did it with iron too, and that saved us a lot of time, because while the two masons who were there were working on the slab, we were taking care of something else. So that was pretty good, it was even better.
And so, after you did your concrete foundations on top, you built, well, I say you, but you all built the straw walls. How did that go? Is there still a wooden frame, or is it really just straw? Can you still see that there are beams, posts?
Yeah, so since the house isn't completely symmetrical, we don't fit into it. For a load-bearing straw house, it's not optimized for load-bearing straw. We're hybrid in many areas. The entire south facade is hybrid with wooden posts since there's no straw. Well, we chose wood, and so overall to build the walls we prefabricated them, and for the floors we prefabricated quite a few wooden elements. So the bottom rails, which are like ladders, are laid flat and doweled into the slab. On the slab we have a capillary break, and we place this wooden ladder doweled through the capillary break. We insulate the bottom rail to prevent thermal bridges. Then we have rods that are embedded in the bottom rail so we can impale the first row of bales.
Here you can see that we're drilling holes in this kind of ladder, which is the bottom rail, so we can insert the rods for the first row.
It's the bamboo.
There you go, the bamboo. Broom handles or laths also use pointed chestnut wood. You have to carve it to a point as well. You can see this gesture, which is still quite important. Remaking the bundle head by hand is called the supporting straw. Some use vaccinium for this. Yes, just trim a bit here and there. We see a photo of someone remaking the head of the target, well, the head of the bundle nice and straight, that's it. It's a small activity within the collective that's still quite important because that's what guarantees the quality. Actually, of the wall.
So we redo all those bundles, we set them properly. So those are the bundles. So the first row on the bottom rail, then we can move on to the second row. And here actually it's like in small masonry, you know. We stagger the joints to avoid having a straight crack in the wall. And we make sure that there aren't any joints less than 30 centimeters apart from each other. And so it's connected from row 4 all the way down to row 1. So here what's good is that it already allows us to have a half height wall that we can already adjust. So row 4, then we go up to row 7. So here it's all going to be on the first floor. Row 7 makes a whole floor. Afterwards, on top, the wooden pieces that we prefabricated before placing the bales, we put them on top of the walls. Here we place wooden box beams on top that match the width of the bales. And here we staple from row 7 to row 4.
So after, on your 7th layer, you put another top plate, that's right, and you start the same thing again on the next floor. 2.
Not yet. Actually, when we put the top plate on the bales there, the wall is still a bit flexible because we haven't compressed the wall yet. So we have all that, a system of temporary and permanent straps.
This image clearly shows the story of permanent and temporary straps. Actually, so the blue straps are the truck straps that really allow you to apply compression. Here, since we have a floor, we really compressed a lot. We compressed the ground floor by 12 centimeters.
So why do you use 2 different types of straps? Why don't you just stick with the truck straps?
What about the truck straps? They have a large ratchet, so we couldn't embed it in the plaster. Here, the advantage of this little loop is that we can cover it with plaster and that's it. Truck straps still cost 20 or 30 euros, so since there are work tools, we collect them at every job site. Actually, here we see that an interesting phase is that we shape the wall with a gardening tool, a brush cutter. The idea is to make the surface as straight as possible so that the plastering phases that come afterward are as quick as possible.
It's like trimming hedges so they're nice and smooth, and then your wall will be nice and smooth too.
And here we can see the next steps, which are quite interesting. So actually we have cladding on the outside, which is very, very unusual for load-bearing straw, and so it's to replace the bracing function of the plaster. We put compressed wood fiber panels that are connected to the top plate and the bottom plate. On top of that, we put the weather barrier, a special weather barrier, because we have openwork cladding, so it's a weather barrier that resists ultraviolet well. It has no writing. There's also a small extra framework on the facade for attaching things. The cladding, because otherwise you can't screw the cladding into the straw. It needs to have some material to be screwed into.
And so, yes, you have these posts actually, which are set into the top plate, the bottom plate, and the intermediate plate. All right, the intermediate plate, because you have 2 floors. And then your cladding naturally goes on top of it.
The top plate, which adds stiffness, is a sturdy wooden piece. You can go straight in with joists, yes, so joists, that makes your upper floor, that's it, I'm making the upper floor.
Okay, and then you do it again, I guess it's the same thing for the second floor, more joists for the roof, and then you guys do the roof. It's cellulose wadding?
It's not from the machine, it's wadding. We thought about it a lot, we wanted to put straw bales in the roof, but what held us back? The bale works best if you keep it mostly in its original shape, about 36 by 46 by 1 meter. We save time as long as it's that shape, but changing it to fit a trapezoid or triangle complicates things. So yeah, for us it was simpler.
During the construction, your straw is exposed, and so there are 2 big risks. 1, if it rains, does the straw get wet? Is that bad? How do we keep our straw dry during construction? And 2, fire. How much can it burn? About these 2 things, what do you have to say?
Yes, you must be careful during construction, but that's true for all sites. When you're working with bituminous waterproofing, it's actually flammable. Plus, there are blowtorches, and when you make sparks near the polystyrene, it can catch fire. Loose straw burns easily, so we set up designated areas for people who smoke. We collect it regularly and move it away.
But baled straw burns really well. Straw bedding ignites quickly, right?
People use the phone book metaphor. A single sheet burns easily, but a whole phone book is hard to light because there's not enough oxygen when it's compressed.
It's important to put the bales on pallets or raise them off the ground to prevent moisture absorption. It's very important to cover them properly before starting the work because they'll probably stay there for 1 or 2 weeks before the project begins.
Especially to protect them from water.
It's super important. We have a kind of moisture meter that allows us to check the moisture level of the bales. You shouldn't use a bale that has more than 20% moisture. In fact, above 20%, it risks composting, and most importantly, it might not be able to dry anymore. It's so dense the water stays in.
If it's over 20%, can we still dry it in the sun and reuse it, or is it unusable?
No, we can't use it because it won't dry. No, professional rules don't allow using bales with over 20%.
And with water, what you have to fear the most is the water that gets in at the top of the wall. Okay, on the side it's not too bad. On the side it's fine, it just runs off actually. Straw is kind of waxy like that and it runs off on the side. During construction we monitor weather forecasts and work when conditions are good. If not, we work under shelter.
That's true, I didn't ask that. So how long does it take to build a house, excluding the endless finishing work? But let's say the main part, the shell, the main structure of the house.
It took us a year, and we moved into the house, we lived in it, and actually we didn't want to live in a construction site. So actually when we moved in, except for the baseboards that still aren't done like everyone else, actually it took us 1 week to assemble the straw bales on the ground floor, 1 week for the upper floor, 1 week for the bales on the upper floor, and 1 week for the roof up there.
So when you mentioned a year in total, you said you have 14 weeks of participatory construction where there are several of you and the rest of the time. How many hours a week did you work on the house?
Mathilde worked full-time while I worked part-time.
Do you have any idea for people?
Later, we hired professionals for the day to help with specific tasks like that.
Okay. Let's finish with that part. Learning how to build with load-bearing straw. Since you're with the association, Mathilde from Toits, Nebraska, specializes in load-bearing straw and office training, which also advocates for spreading, popularizing, and democratizing load-bearing straw construction. Can you tell us a bit about this initiative and the future of straw construction?
So the association has existed for 6 years, since 2016, and our real ambition is to build, to construct and design demonstration buildings. So we've already done several projects over the past 6 years, and we're increasingly moving towards development, including regulatory aspects. So for the past 3 years, we've been working on best practice guidelines. So we hope to raise them to a guide of good practices or even professional standards. That would be ideal. Alongside that, we provide training. So we have several types of training. We've talked about on-site training. We have a week-long training course of 35 hours, which is more geared towards professionals. Archie Company Design Office, Inspection Office. So here we cover design, calculation methods, structure, how to innovate with confidence, and construction site work. We actually build a 3x3 meter wall and apply coatings to it together for a week. For the first time, we're holding a 2-day training session, already full for June. We'll do it again, and this time it's more hands-on and spans 2 days. Actually, we're building a wall. We're building the model wall for the 35-hour week. So we built this 3-meter wall in 2 days and spent less time on computers, engaging more in questions and answers. We're really happy because for 6 years we've proven that load-bearing straw works. We could build straight upright buildings with floors that aren't tiny and not a lot of openings. We do contemporary architecture with many openings and nearly meet passive standards. We're playing in the big leagues. Actually, since the 10-year warranty we remain very interested. Actually, to reduce construction costs, because that was the way to go to make load-bearing straw credible. After that, we'll build more demonstration buildings and plant pro flags to show load-bearing straw works. There's no reason not to go for it, including public markets, passive buildings and company inspection offices. There's no reason not to. But we really want to keep a significant amount of time towards people who want to do self-construction, to support them. I think it would save time and certainly money. Because getting help, you move so much faster to build buildings that really don't cost much. That's really part of our intentions, because Mathilde and I, and then Gilles, Peter and Sami. In any case, we have a social approach that is, it's visible, though less so now since we focused on the technical side, but the social approach is essential to all we do.
Thank you for everything, Cedric.
With pleasure.
Great, thank you very much, thank you. What more can I say? This video still brought a lot of things. If you have questions in the comments, feel free to ask. Cedric, Mathilde and others will be mentioned in the description or comments. Answer these questions and add more points. Keep the debate going as the discussion never ends. We'll also put some sources for books or things about straw construction. To go further, don't hesitate to share this video as much as possible to help convert more people to the topic of load-bearing straw. Also, feel free to support us on Tipeee to help us finance the next videos and upcoming reports like this. And I'll see you very soon on the channel for more videos. Thank you. Goodbye. Goodbye.